Welcome students to the 17th lecture of the MOOCs course on Introduction to Fuzzy Sets, Arithmetic and Logic. In today's class, we shall be doing solving of fuzzy equations. As you can well understand that solution of equations is very important, particularly when we are designing systems that needs us to handle fuzzy mathematics to a significant extent. In particular, we shall look at two different types of equations. One is linear equation, a plus x is equal to b, another is a multiplicative equation a star x is equal to b, where a and b are fuzzy numbers and x is also expected to be a fuzzy number. Why I am saying expected? Because sometimes there may be a trivial solution where x is only one real number. We shall see that later. So, let us first start with a plus x is equal to b. Now, if a and b are reals, we get straightforward solution x is equal to b minus a. Does it work for fuzzy numbers? The answer is no. Why? The reason is very simple. Let us illustrate using interval arithmetic. Suppose support of A is equal to A1, A2. It is the closed interval on which set A is defined, and support of B, B1 comma B2. Then B minus A, as we know, its support is going to be B1 minus A2 comma B2 minus A1, because you know we have already done these things that it will be most negative, the value will be B1 minus B2, and most positive value that it can have is B2 minus A1. Therefore, A plus B minus A is equal to B1 minus A2 plus A1 comma B2 minus A1 plus A 2, and we know that this is not equal to B 1 B 2. So, this shows that we cannot get a solution by simply subtracting A from B. However, we can easily see that one possible solution is B 1 minus A 1 comma B 2 minus A 2, and it is obvious that A 1 comma A 2 plus this interval B 1 minus A 1 comma B 2 minus A 2 is equal to B 1 comma B 2. But it is not so simple. There is a catch. B 1 minus A 1 comma B 2 minus A 2 need not be a valid interval. Example, consider A is equal to the triangular fuzzy number minus 3, 1, 9, and B is equal to also the TFN minus 1, 2, 3. Therefore, support of A is equal to minus 3 comma 9, support of B is equal to minus 1 comma 3. Therefore, B 1 minus A 1 comma B 2 minus A 2 is equal to minus 1 minus minus 3 comma 3 minus 9 is equal to 2 comma minus 6, and we see that this is not a valid interval. However, if the given equation is minus 3, 1, 2 plus x is equal to minus 1, 6, 8, and then the B 1 minus A 1 comma B 2 minus A 2 is equal to minus 1 plus 3 comma 8 minus 2 is equal to 2 comma 6, which is a valid interval. But the catch is that this validity should hold for all alpha cuts, because we know alpha cut of A plus alpha cut of x is equal to alpha cut of B. So, consider again A is equal to minus 3, 1, 2, B is equal to minus 1, 6, 8. Therefore, alpha cut of A is equal to minus 3 plus 4 alpha comma 2 minus alpha, and alpha cut of B is equal to minus 1 plus 7 alpha comma 8 minus 2 alpha. Therefore, alpha cut of x is equal to, we get by subtracting alpha cut of A from alpha cut of B, and we get this is going to be 3 alpha plus 2 comma 6 minus alpha. Since alpha cut of x is equal to 3 alpha plus 2 comma 6 minus alpha, we can obtain the fuzzy number x, and mu A of x, mu x of x is equal to 0 if x less than equal to 2 or x greater than equal to 6. Because putting alpha is equal to 0, we get that this support is 2 to 6, and putting alpha is equal to 1, we can see that the mode is equal to 5. Therefore, if x is between 2 and 5, we get the equation to be, we get the membership to be x minus 2 upon 3. In a similar way, when 5 less than equal to x less than equal to 6, we get the membership to be 6 minus x. Therefore, in this case we get a solution. Thus, the conclusion is that all the time you may not get a solution for A plus x is equal to B when A and B are fuzzy numbers. We have to check the validity, and then only we can be sure that the fuzzy equation can be solved. Let us now look at solution for A dot x is equal to B, that is, we are looking at multiplicative equation where A and B are fuzzy numbers. As before, we go by interval arithmetic. Let the support of A be A1 comma A2 and support of B is equal to B1 comma B2. Now, there are three possibilities for A and B. 0 less than equal to A1 less than equal to A2. That means A is an interval on R plus. Second one is A1 less than equal to 0 less than equal to A2. That means we are considering intervals from negative side of the real line to the positive side of the real line. And the third option is that A1 less than equal to A2 less than equal to 0. That means both A1 and A2 are negative. That means the entire interval is on the negative side of the real line. Similarly, we have three possibilities: 0 less than equal to B1 less than equal to B2, B1 less than equal to 0 less than equal to B2, and thirdly B1 less than equal to B2 less than equal to 0. Now, for A, any of the three situations can be a possibility. Similarly, for B, any of the three situations may be a possibility. Therefore, the equation A x is equal to B may have 9 different possibilities with respect to the support of A and B. Therefore, whether a solution actually exists or not, in order to find that, we have to look at the particular situation of the given problem, and then we have to see whether a solution is possible or not, because we shall see that in all of the 9 cases solutions may not be possible. So, let us look at case 1, when 0 less than equal to A1 less than equal to A2 and 0 less than equal to B1 less than equal to B2. We can observe that A1 A2 multiplied by B1 upon A1 comma B2 upon A2 will give the interval B1 B2. Therefore, one may think that B1 upon A1 comma B2 upon A2 may be the support for the unknown quantity x. So, let us consider examples, and we are in the interval arithmetic mode, and the equation to be solved suppose is 2 comma 3 star x 1 comma x 2 is equal to 5 comma 9. Therefore, by the above observation, x may be 5 by 2 comma 9 by 3 is equal to 2.5 comma 3, and this is accepted because this is a valid interval. But consider example 2, 2 comma 3 star x 1 comma x 2 is equal to 4 comma 5. Therefore, B1 upon A1 is equal to 2 and B2 upon A2 is equal to 5 by 3. Thus, x can be 2 comma 5 by 3, which is not a valid interval. Thus, in the second case, we do not have a solution. Therefore, the condition that when both A and B belong to R plus, that means positive reals, then solution exists if B1 upon A1 is less than equal to B2 upon A2. As before, this should hold for all alpha cuts hence, the conditions for existence of solution for A star x is equal to B when A comma B belong to R plus R alpha cut of B 1 upon alpha cut of A 1 is less than equal to alpha cut of B 2 upon alpha cut of A 2 for all alpha belonging to 0, 1. This is needed so that validity of the solution is ensured. And the second condition is for alpha less than beta, we have alpha cut of B 1 upon alpha cut of A 1 is less than equal to beta cut of B 1 upon beta cut of A 1 is less than equal to beta cut of B 2 upon beta cut of A 2 less than equal to alpha cut of B 2 upon alpha cut of A 2. That is, if alpha cut of A is equal to alpha cut A 1 comma alpha cut A 2 and alpha cut of B is equal to alpha cut of B 1 comma alpha cut of B 2, then the above inequalities should hold for all alpha less than beta, because this will ensure that beta cut of x is contained in alpha cut of x. Now, let us look at case 2, when A is positive, but B is like this. That means, B is an interval which spans from negative side of the real line to the positive side of the real line. Now, if x is the solution, let support of x be x 1 comma x 2. Therefore, we can have three situations. On one hand, we have 0 less than equal to A 1 less than equal to A 2, but we have three cases: 0 less than equal to x 1 less than equal to x 2, x 1 less than equal to 0 less than equal to x 2, and the third case is x 1 less than equal to x 2 less than equal to 0. But you note that my B is from negative to positive. So, if we multiply, let us see whether we can get this or not. In this case, we can see that A star x will be A 1 x 1 comma A 2 x 2, and both are positive. because A1 is positive, x1 is positive, A2 positive, x2 positive. Therefore, both of them are positive. In this case, when A1 and A2 are positive and x1 is negative and x2 is positive, then A star x can have this interval, which is A2 x1, A2 x1, comma A2 x2, and we can see that it is negative to positive, because x1 is negative, therefore, A2 x1 is negative. In a similar way, since x2 is positive and A2 is positive, A2 x2 is positive, and if we look at the third case, both of them are less than 0, we can see that this interval is going to be A2 x1, comma A1 x2, when both are negative. So, this simple observation suggests that if there is a solution, then this is the case. Therefore, if a solution exists, then A2 x1, comma A2 x2 is equal to B1, comma B2. Therefore, x1, comma x2 is equal to B1 upon A2, comma B2 upon A2. Therefore, in this case, we shall always get a solution. Let us now consider case 3, which is 0 less than equal to A1 less than equal to A2 and B1 less than equal to B2 less than equal to 0. Therefore, to obtain a solution, we must have x1 less than equal to x2 less than equal to 0, because A is completely positive, B is a completely negative. Therefore, unless x is all negative, we cannot get a solution in this case. Therefore, A1, comma A2 star x1, comma x2 is equal to B1, comma B2 implies, now this is positive, this is negative. Therefore, maximum possible negativity, the maximum negative value will be A2 x1 and the minimum negative value will be A1 x2. Therefore, if the solution holds, then A2 x1, comma A1 x2 is equal to B1, comma B2, or x1 is equal to B1 upon B2 and x2 is equal to B2 A2 and x2 is equal to B2 upon A1. Therefore, like case 1, solution will exist if B1 upon A2 is less than equal to B2 upon A1. So, let us take examples. One is that 4 comma 9 star x1 comma x2 is equal to say minus 5 comma minus 3. Therefore, B1 upon A2 is equal to minus 5 upon 9 and B2 upon A1 is equal to minus 3 upon 4. So, this is roughly is equal to minus 0.55, but this is minus 0.75. Therefore, this is not a valid interval. Therefore, no solution exists. However, case B, 2 comma 6 star A1 x1 comma x2 is equal to minus 4 minus 1. If that is the problem given, then B1 upon A2 is equal to minus 4 upon 6 and B2 upon A1 is equal to minus 1 upon 2. Therefore, the interval is minus 2 by 3 to minus half, which is a valid interval. Therefore, solution will exist. In a symmetric way, one can deal with the three situations pertaining to A1 less than equal to A2 less than equal to 0. Very similar to the case that we have seen, because in earlier case they were all positive, now they are all negative. So, I leave it as an exercise to see when solution will exist and when it will not. So, our focus is now on A1 less than equal to 0 less than equal to A2. Here let us look at case 1. So, case 1, 0 less than equal to B1 less than equal to B2. As before, we have three cases. We have A1 less than equal to 0 less than equal to A2, and the three cases are 0 less than equal to x1 less than equal to x2, x1 less than equal to 0 less than equal to x2, and the third case is that x1 less than equal to x2 less than equal to 0. In this case, the lower bound is a1 x1, which is less than equal to 0. Therefore, rejected. In this case, the upper bound is a2 x2, which is also less than 0. Note that. So, only situation remaining is x1 less than equal to 0 less than equal to x2. Therefore, a1 x2 will be negative, hence rejected. Therefore, if this is the situation that a1 less than equal to 0 less than equal to a2, but 0 less than equal to b1 less than equal to b2, there does not exist any solution. In a similar way, we can show that a1 less than equal to 0 less than equal to a2 and b1 less than equal to b2 less than equal to 0 do not have any solution. Therefore, the most complicated situation is when a1 less than equal to 0 less than equal to a2 and b1 less than equal to 0 less than equal to b2. So, we have to look at the following quantities. b1 upon a1, which is going to be positive, and b1 upon a2, which is going to be negative, and b2 upon a2, this is going to be positive, and b2 upon a1 is going to be negative. Therefore, we shall have to look at the alternatives which alternative can give us the support. Let us give an example. A1 comma A2 is equal to minus 3 comma 2, B1 comma B2 is equal to minus 4 comma 9. Therefore, B1 upon A1 is equal to 4 by 3, B1 upon A2 is equal to 4 by minus 2 is equal to minus 2, B2 upon A1 is equal to minus 9 upon 3 is equal to minus 3, and B2 upon A2 is equal to 9 by 2. Therefore, we check the following intervals for possibility of x1, x2, and they can be minus 2 comma 4 by 3, minus 2 comma 9 by 2, minus 3 comma 4 by 3, 4, minus 2 comma minus 3 comma 9 by 2. Also, we need to look at minus 2, the singleton one, minus 3, the singleton one, minus 2 comma minus 3, similarly 4 by 3, 9 by 2, and 4 by 3 comma 9 by 2. So, these are the 6 possibilities. So, let me number them 5, 6, 7, 8, 9 and 10. So, if the solution exists, any one of them should give us the answer. As before, here we are looking at only the interval arithmetic, but this has to be valid for all alpha cuts, alpha belonging to 0, 1. So, how to find it for all alpha cuts? I give you a trick. Consider a situation when A1 less than equal to 0 less than equal to A2 and B1 less than equal to 0 and less than equal to B2. We draw the following diagram. Suppose this is 0 and the equation is this is A1, this is A2, and suppose B1 is so. This is zone 1 where A1 is alpha cut of A1 is less than 0 and alpha cut of A2 is greater than 0 and alpha cut of B1 is less than 0, alpha cutoff B 2 is greater than 0. Now, let us look at this zone. Here A 2 is becoming negative to positive, and if I call it zone 2, then what we find in zone 2 is that this was zone 1. Zone 2 is alpha cut of A 1 is less than 0 and less than alpha cut of A 2, but alpha cut of B 1 is greater than 0, is greater than equal to alpha cut of B 2. Here both B 1 and B 2 are positive. And then there is the zone 3. In this region, what we are getting? Alpha cut of A 1 is less than alpha cut of A 2 is less than 0, but beta cut of alpha cut of B 1 less than alpha cut of B 2, and both are positive. So, like that, wherever the lines are crossing the y axis, we have to split it into different zones. With respect to each zone, we get the conditions, and the way we have solved earlier, we have to see if for this zone solution exists or not. Like that, after analyzing all the cases, we can ascertain if we can get a solution for the given multiplicative fuzzy equation. Okay, students, I stop here today. If you want, I can upload a small document where it will analyze all cases and will give you clues to in which situation one can find a solution. Okay, thank you so much. With this, I complete my lectures on fuzzy arithmetic. In the next class, I shall start with fuzzy relations. Thank you.